Atacama Oases. It's not about what you see, it's about what you hear, so you can truly understand. Our goal is to reach 100,000 subscribers. Be one of our very first supporters.
Did you know there's a moon in our solar system that's actually bigger than the planet Mercury? And have you heard that it's the only known moon to have its very own magnetic field? How on earth could a cold, icy moon generate heat from the inside out? And why has this moon been totally baffling scientists for decades? This is Ganymede, the largest moon of Jupiter, and today we're going to uncover its hidden secrets together. Ganymede is the seventh moon of Jupiter by distance, and it whips around that giant planet in just about 7 days. Just like Earth orbits the Sun, this massive moon circles Jupiter at a speed of over 10 kilometers per second. This moon was first discovered by the Italian astronomer Galileo Galilei back on January 7, 1610, and it's been a total puzzle to scientists ever since because of how unique it is compared to every other moon in the solar system. Ever since its discovery 4 centuries ago, scientists have noticed that Ganymede is just built different compared to all the other moons. Then, back in 1996, NASA's Galileo spacecraft dropped a total bombshell. This moon actually has its own magnetic field. And this isn't just some random quirk, it's like a massive protective bubble surrounding the moon, shielding it from all that gnarly space radiation. That discovery makes Ganymede one of a kind, since it's the only known moon in the entire solar system that generates its own magnetic field from the inside. Just like Earth produces its magnetic field from a molten metal core, Ganymede is doing the exact same thing, even though it's way smaller and freezing cold. But seriously, how can an icy moon keep a molten core like that? The answer is all down to 2 main heat sources. The first one is natural radioactive decay, where heavy elements like potassium-40 inside the moon break down and constantly crank out heat. It basically means the inside of Ganymede is holding onto a natural nuclear furnace that's been running for billions of years, keeping that iron molten even though space around it is absolutely freezing. As for the second source, it's those insane gravitational forces from Jupiter. Jupiter, being the absolute titan of our solar system, exerts this massive gravitational pull on Ganymede, causing the moon to constantly get squeezed and stretched. Just imagine taking a ball of clay and kneading it over and over. You'd actually feel the heat generated from all that flexing, right? This process, which scientists call tidal heating, is literally just like how dough heats up when you're kneading it because of all that friction. And over time, chunks of molten iron started sinking down toward the center of the moon. Just like how sediment settles at the bottom of a glass of water, the heavy iron sank down to the core to form a metallic heart that's still growing today. And here is the massive surprise. Recent studies actually suggest that the formation of this metallic core might not even be finished yet. According to the cold start model, Ganymede actually formed as this cold, mixed-up blob of ice, rock, and metal, and it's taken billions of years for its inner layers to gradually warm up. This means Ganymede's core might actually still be in the middle of forming today, which is a phenomenon we haven't seen on any other known object. While the cores of other planets and moons cooled down and solidified ages ago, Ganymede is still slowly heating up from the inside. And that super slow core formation is exactly what's fueling the magnetic dynamo and keeping the moon's magnetic field alive and kicking. But that begs the question, why is Ganymede the only one, especially compared to Jupiter's other moons? Take Callisto. It's super similar in size and density, but it doesn't show any clear signs of having a magnetic dynamo. Scientists think the difference all comes down to the exact composition of the rocks and the specific amount of tidal heating each moon gets hit with. Ganymede has rocks that are way less water-rich than Callisto's, which really helped its internal temperature soar. Plus, those tidal forces from Jupiter hit it way harder because of exactly where it's sitting in its orbit. Both of those factors together turned Ganymede into the perfect environment for a molten metal core to form, while Callisto just stayed cold and frozen solid. To lock in these theories, the European Space Agency is getting ready to send the JUICE mission straight to Jupiter's icy moons. This probe is set to hit the Jovian system by 2031 and will actually settle into an orbit around Ganymede itself by 2034. It's going to be pulling in super precise data on that magnetic field and exactly what the moon is made of on the inside. Recent data from NASA's Juno probe, which zoomed past Ganymede back in 2021, has also been a game-changer for understanding what's going on inside. By analyzing the moon's gravity field, scientists were able to estimate the size of its metallic core, which has a radius anywhere between 400 and 1,200 kilometers. Putting all this data together is finally painting a way clearer picture of this mysterious, icy world. Understanding how magnetic fields form on these far-off moons is honestly opening up a whole new world in the search for habitable planets. A magnetic field plays a supercritical role in shielding celestial bodies from those harsh, nasty cosmic rays. So by studying Ganymede, we're actually getting a much better grasp on how other worlds could potentially protect life, if it's out there from all that destructive radiation. And just like that, Ganymede stands tall in the Jovian sky as the largest moon in the entire solar system, holding on to deep secrets about how planets are born and evolve. From being a cold, icy moon to a world that's literally heating up from the inside and rocking a one-of-a-kind magnetic field, Ganymede proves that the universe is still packing plenty of surprises just waiting for us to uncover them.